Hi everyone, this is Yukabuka and welcome to my home on YouTube. This is going to be the fourth episode in a series of videos about kobject and its use in the Linux kernel. So, resuming from where we had left off in our previous video, let's have a look at U-events. After a kobject has been registered with the kobject core, you need to announce to the world that it has been created. This can be done with a call to kobject U-event. Okay, we did see a call to kobject U-event earlier. I believe it was from the function kobject add. Yeah, was it inside add though? It could have been inside init as well. Let's take a quick look. We did see that function earlier, but I don't quite recall where we saw it. We can take a quick look. Kobject U-event. So if you look for references to this, we are looking for references to this. Oh, there are quite a few, but we are interested in the ones here. Not this one. 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 Kobject U-event. This could have been the one. I'm not too sure though. Yes, this is the one, I believe. It did have a kobj underscore add, if I remember correctly. We saw it in the context of a notification being sent to user space. So let's see. I guess I'll just have to refer to the earlier videos myself, because I don't quite remember where that function, where I had encountered that function earlier. In any case, let's have a look at this function. The description says that it can notify user space by sending a U-event, and the function returns 0 if it's completed with success or if the corresponding error when it fails. Sounds good. So it takes a kobject and a kobject action. So you have kobject add, remove, change, move, and so on. Right, I think the earlier one we saw was a kobject move and a kobject add. In any case, so if we go inside kobject U-event env, we see a function, a rather large function. Let's have a look at the description. It sends a U-event with environmental data, and I believe this is probably what they're referring to by environmental data. And it returns 0 if it is completed successfully, and so on. We have a kobject, a kobject action, and an environment. Let's see what this function does. So the helpful comment here says that first we search for the kset that we belong to. And in order to do that, we temporarily assign kobject to top kobject, and while top kobject arrow kset and top kobject arrow parent traverse all the way up. Okay, that makes sense. So we traverse towards the kobject which has a parent and has kset set to null, I believe. For example, in this case, if top kobject arrow kset was null, then we would loop. But if it were not null, then we wouldn't really enter this loop at all. So we are effectively finding the lowest kobject whose kset is set. If not, we iterate towards its parent and so on. Rest assured, the topmost kobject should have a kset set. Okay. Now, and that's exactly what's being checked here. If the topmost one does not have a kset, then we have a error message being printed out. We take a reference to the kset from the top object, kobject, and we get kset arrow uEvent ops and store that locally in uEvent ops. And the type of uEvent ops is kset uEvent ops. And that structure is a structure of function pointers. It contains a filter, a name, and a uEvent. Okay, I wonder if these are callback functions of some sort, but at this point in time I don't know. The next comment helpfully says that skip the event if uEvent suppress is set. Right, so it is possible apparently for a kobject to say that a uEvent does not need to be broadcast to user space, and that is done by setting the kobject's uEvent suppress flag. I wonder if it's a bit field. Yes, it's a bit field. Okay, and the next helpful comment says that skip the event if the filter returns 0. So what's happening here is that the uEvent ops has a filter function, as we saw earlier. So if uEvent ops and uEvent arrow filter or uEvent ops arrow filter is set, the filter function needs to be called, and only if the filter function returns a non-zero value do we proceed with passing this uEvent to user space. So effectively the filter function pointer is to be set to a function that will determine if this uEvent needs to be passed to user space or not. If the function returns a 0, then the uEvent will not be passed to user space. Makes sense? The next one is the originating subsystem. Okay, so this seems to be an attempt at finding which subsystem the kobject is a part of, or rather which structure the kobject is embedded in. So if uEvent ops and uEvent ops arrow name is set, name also being a function pointer, then the subsystem is obtained by calling the name function pointer. Okay, so in effect uEvent ops arrow name is a function pointer such that upon calling the function it retrieves the name of the subsystem the kobject belongs to. Okay, that makes sense. The next one is a subsystem. If that is not the case, if this uEvent ops value is not set, you can obtain the subsystem by using kobject underscore name of kset arrow kobject. Okay, So I believe we did see kobject underscore name earlier, and they mentioned that this is a helper function to both initialize. Oh no, sorry. They mentioned that it is a function to access the name of a kobject, right? So we did have a look at this function in the previous video, and so the subsystem is set to kobject name. Okay. It is interesting to see that this is not called with the kobject that was passed into this function, but rather the kobject that is embedded into the kset. Okay. So if not subsystem, then you print out an error message. So at this point, I'm still a bit fuzzy about the complete relationship between a kset and a kobject. We know that a kset embeds within itself a kobject, and we also know that a kset has a list head item which makes it a part of a list of kset objects. Earlier in the code, we saw that a kobject instance was being added into the subsystem, and at that point the parent of the kobject was set based on the kset's kobject. But apart from that, it hasn't been very clear how a kset is related to a kobject. And so let me just do a quick search to see if kobject and kset, if someone has answered this. There is a PPT here. At this point, it's not very clear to me, so I will find some resources and try to figure it out and make a video on that soon. Okay, so over here we try to find the originating subsystem, and again we have a helpful comment that says environment buffer, where a kobject uEvent env type struct is allocated. Okay, so this seems to be the structure that's used to pass information to user space. You have a array of 3 pointers, an array of uEvent num environment pointers, and a buffer, and with its buffer length. So in this case, env is a pointer to one such dynamically allocated instance of struct kobj uEvent env. We also get the complete object path using kobject get path. We did look at how kobject get path is implemented in the previous video, and this section, the comment says that it's default keys. So I'm not quite sure what that means. There is a add uEvent var, which is a function that adds a key value string to the environment buffer. Okay, so the environment buffer was allocated over here, and we pass a key value pair into this function, and it gets added into environment. So there are three cases where this function is called with different keys. I believe it's the action equals %s, def path equals %s, and subsystem equals %s, and different value, which should be action string, def path, and subsystem. If we look at action string, let me just quickly recall where that came from. Right, so action string is a static collection of strings which just gives you a string representation of whatever the action is. Okay, that makes sense. And what else do we have? Okay, we can take a look at how add uEvent_var works. Return 0 if the environment variable was added successfully, or return -enomem if no space was available. Right. So if env idx is greater than the array size of envp, then too many keys, return enomem. Else you take each of these and pass it through and save it into env arrow buff, right? And once you are done with that, what is this? If length is greater than the size of buff or env arrow bufflen, you say that the buffer size is too small. Right. But that's a bit strange because you've already copied the content into env arrow buff, haven't you? So let's see. What if you check the man page of man vsn printf, vsn printf, you have sort of a vsn printf. You have a string, you have a size, you have a format, and an AP, right? So in this case, and it returns a length, right? The functions do not write more than size bytes. Okay. If the output was truncated due to this limit, then the return value is the number of characters which should have been written to the final string if space had been available. Right. Okay. So in this check says that if the space had been available, these are the number of characters that would have been written. So if this length here is greater than the size of env buff minus env arrow bufflen, then that means that the content was not written properly into the buffer, and so you return enomem. So there isn't, it doesn't seem like there is an overflow here. Env arrow envp of env arrow envp idx plus plus is the address of this buffer over here. Okay, sounds good. And then you have bufflen is equal to ln plus 1. Sounds good. So the idea is that in the buffer here you store various key value pairs, and in envp you store pointers to the start addresses of the various key value pairs. As for the argv, it does not seem to be used here. Let's go back and check if it's used somewhere, but that's pretty much it. There are also keys passed in from the caller. So these are keys that are always set into the environment, and there are keys that are passed in from the caller as well. So in a loop we set those onto the env using add uEvent_var. Now this comment here says that let the kset specific function add its stuff. Okay, I'm not quite sure what that means, but what it's doing is it's checking if uEvent ops is set and if uEvent ops uEvent is set, and if so, it calls that function pointer using kset, kobject, and env, presumably so that the function can add its own key value pairs into the environment, right? So if a kobject needs to add its own key value pairs, if a kobject wants to add its own key value pairs into the environment and send it to user space, it has two options. One is to send it into the function directly, kobject uEvent env. The second is to have a kset which has its uEvent underscore ops arrow uEvent set to a function which will add those contents to the env variable. Okay. What's happening here next is you do a switch on the action. It could be add, remove, or unbind. And according to that, you set various bit fields inside the kobject. The comment here says mark an add event so we can make sure we deliver the remove event to user space during automatic cleanup. I see. If the object did send an add event, remove will automatically be generated by the core if it has not already been done by the caller. Okay. So the reason state add uEvent send is set is so that when it's time for cleanup, the core can automatically send a uEvent saying that this is being removed and send it off to user space. Interesting. Okay, we see that there is a critical section here. There is a mutex that has been acquired and released. And in this critical section, what it does is we will send an event, so we request a new sequence number. Okay, interesting. And apparently uEvent sequence number is a 64-bit global variable, and that is added into the environment variable before sending it to user space. Okay, and once that is done, you do a kobject uEvent net broadcast and then release the lock. So this seems to be the function which eventually sends the content to user space. Over here we have a bit of code within the ifdef macro, and the ifdef macro is named config uEvent helper, and apparently the comment says that this is only enabled during early boot. So is uEvent helper a okay, it's a car array of some sort, and all it does is set some more specific key value pairs into the environment and call a user mode helper setup. So I'm not quite sure what this is, but we will need to dive into this. Before we get into the blob of code over here, let's take a look at how it sends the uEvents to user space by inspecting this function here. So the way this function sends the content to user space is as follows. We have this function takes as argument a kobject uEvent env, an action string, and a def path. And there is a huge if-def statement over here, such that if the kernel is not compiled with config net, then this simply just won't work. Within that, you have a skbuff structure pointer, and you have a uEvent sock. In the next loop here, we see that it goes all the way up till here. There is a function list for each entry where it goes through a global list called uEvent sock list, and checks if the uEvent sock obtained from each item on the list has listeners, and if so, and if it does not have listeners, then don't bother sending this message over that socket. That's what it's doing. Okay. If not skb, you allocate each message with the maximum possible size. Okay, you allocate the skb over here, you add a header onto it, you copy the data onto it, and then you call netlink broadcast filtered in order to send this message. So effectively the data is sent to user space via netlink sockets. Netlink is again a subsystem of its own, which we can dive into later, but that is what's happening over here. It's interesting to see that there is a list of uEvent sockets that are maintained, and when the broadcast happens, this code here checks if there is any listener on that specific socket, and to every socket that has a listener that is on this list, the kernel broadcasts the constructed env to user space. Okay. So now that we've looked at that part, we can come back to this section here about a config uEvent helper. We read in the comments earlier that this is only enabled during early boot, so I'm not quite sure what part of early boot this is used in. We see that it's adding a few key value pairs into the environment, but what does it do with those additional key value pairs? We have a function here called init uEvent argv. But I'm not too sure. It seems to be setting some values into the argv part of the env that is passed into user space, and it does have a call user mode helper setup function that is called. So what maybe the comment for this function can give us some insight into this. Return either null or an allocation failure or a subprocess info structure. This should be passed to call user mode helper exec to exec the process and free the structure. The init function is used to customize the helper function prior to exec. This part of the code here, it's not immediately obvious to me why this is present, but yes, if you have any ideas, feel free to leave a comment, or else I can later on figure this out and make a video on that. Okay, so at the moment we have seen how kobject uEvent constructs a message with all the key value pairs, how it obtains these arguments, how it adds them to the buffer, and how it sends it off to user space via netlink sockets. Let's have a quick look at this. It says that use the kobject add for when the kobject is first added to the kernel. This should be done only after any attributes or children of the kobject have been initialized properly, as user space will instantly start to look for them when this call happens. Right. When the kobject is removed from the kernel, details on how to do that are below. The uEvent for kobj remove will automatically be created by the kobject core, so that the caller does not have to worry about doing that by hand. Yes, we did see this while reading the source code. Okay, so in this section we have looked at how kobject uEvents can be used from within the kernel. In the next video we will look at how reference counting works by using kobjects. Hit like if you enjoyed the video and subscribe to the channel for more updates.